So I want to introduce an idea that's going to be useful to us here in a second to analyze one of these application problems we've been looking at, and that's this notion of inverse functions. And this is already an idea that you're familiar with, although not everybody may have called it this. So an example of an inverse function is something like, well, x plus 5 minus 5, well, that's just equal to x, right? So that's an example of an inverse function. So sort of casual definition and not very rigorous definition is a function. Functions are inverses if they undo each other, right? So plus 5 and minus 5 are opposites and they cancel out, right? So again, this is a super familiar idea from earlier in your math career. Another example that's going to come up here in a second is, let's say I want to isolate x in this expression here. Well, to do that, say I was trying to solve for x, I would take the square root of both sides of my equation, and that would give me just a plain old x by itself, right? So these, again, we'd say are inverses, the square root function and x squared. And remember, we're talking about exponential functions, so these exponents are going to become important here in a second. So let's look at this context here. So this is something that you might run into in your life, although not for a while, unless you get real rich real quick. Suppose you're planning for retirement, right? And we already know the math of like building a model of how an investment would grow towards retirement. But what we don't know how to do is figure out at what interest rate do I need to invest? How much do I need to be earning to meet a target goal, right? So let's say I want to retire at 65 with $80,000 in the bank, which is not nearly enough to retire on, by the way. We need to do a little bit of math to figure out what interest rate I need to be earning on my $32,000 to get there, right? And we know we're investing for 15 years here. So my setup is going to be the same here. So I'm going to use the formula that we've seen in previous modules. So here's my setup, right? I use my formula that I'm familiar with. My n is 12 because it tells me that interest is compounded monthly. But I've left r in the formula because r is what I'm trying to find, what interest rate it says. So r is what I'm trying to find. Everything else I've plugged in. So 32,000 is my starting value, 80,000 is my y, is my goal, and 15 is my time, right? So now I can start to simplify this a little bit. So I'll simplify 12 times 15. And then I want to divide both sides by 32,000 because what I'm trying to do, right, is get to r. I want to isolate that. So I'm going to divide 32,000 on both sides. So this is all math you know how to do. So you might have been able to figure this out on your own. And then here's where we have to be a little bit smart. So notice I have this 180, this exponent that is keeping r from being isolated. So I have to do the opposite of raising something to the power of 180. So my needed fact here is that roots are the same as fractional exponents. So what I have to do is take the 180th root, just like I took a square root up here. So my needed fact is that the square root of x is the same as x to the 1/2 power. And the way we'd write this here is the 180th root of x is equal to x to the 1 over 180th power. These are called rational exponents. So to solve my equation here, well, I can just take both sides raised to the 1 over the 180th power. And what I get, right, is these cancel out, and this I can just type into my calculator and I'll get a decimal. So I would say take your calculator, you're going to use a little caret and type this in. Make sure you can get the same result that I do. That result is 0.0051, and that's gotten rid of my exponent. So I have 1 plus r over 12, and then I can solve that just like I'm familiar with, subtract 1 on both sides and multiply times 12. And the result there is a result of 6%. So that's the interest rate I need in order to retire at 65 with my goal. Okay. So again, the key thing, the thing that we're adding, all of this math, the setup and the solution are familiar to you. But what we're adding here is this notion of using a rational exponent to undo an exponent. We'll look at a harder example now here. So here I'm given 2 points and I'm told that my function is exponential. So this is our basic ab to the x exponential. And this is actually really clever how we're going to tackle this. So what I can do, notice first of all that neither of my x's is 0. So here's an x, here's an x. They're both bigger than 0. So if x was 0, I'd be given my a right away, and that would be pretty easy, right? But I'm not, so I have to be a little bit smarter here. What I'm going to do, sort of like if this were a linear equation I'm trying to find, is I'm going to build an equation to help me figure out a and b, just like if I was finding y-intercept and slope, right? So the equation is going to be, here's a y, 27 is equal to a times b to the 3.5 is my x, and that's an exponent. So that's one equation I can use to find my a and b. My other equation, very similarly, right, is 14 is equal to ab to the 2. So that's something you already know how to do. I just plugged in an x and a y, and it's going to help me solve for my a and b. Now, here's where I'm going to be really clever. So I'm going to divide these two equations by each other. You've already added and subtracted equations to each other, like solving systems and stuff. Here I'm doing the same thing, just a different operation. And look what happens here. So my a's cancel out. A over a is 1. And then when I'm dividing 2 powers of b, I subtract the exponents. So I get b to the 1.5, whoops, is equal to 27 over 14 on the left. And I can do that because both sides are equal to each other. So I'm dividing the same thing on both sides. Okay? Now I have an equation that I can solve using my fractional exponents. So to do that, I'm going to raise both sides by the opposite power, which is 1 over 1.5. And you do want to leave the left as a fraction when you can, because it'll be easier to type in on your calculator. So on the right, these cancel out, and I end up with my b. My b is whatever that 27 over 14 to 1 over 1.5 is, which is 1.549. And then I'm almost done. So I get f of x equals a times 1.549 to that. So I still need to find my a, and the way I do that, well, you probably already know, is I plug in a point and I can solve that way. So 27 was the y I picked, so my x has to be 3.5. And notice here, all I need to do is type this into my calculator to simplify. So I make sure you can get that. And then I just divide both sides by that number, and I get 5.83. So my whole function, and we're almost done now, we'll put it all together. We'll say f of x is, well, my a times b to the x. And then that means that, remember, I'm trying to find f of 7. My last step would be to plug it in. I'll leave that to you. And that would be my answer, whatever I get here.